Hello all, my name is Ram Morla. I have spent the last 35 years and odd bridging the gap between complex data architecture and business outcomes in the insurance, banking, and financial services sector. I specialize in building trusted data ecosystems that scale. I distinguish my approach through two proprietary innovations. They are my own. First, my Resilient by Design data governance framework, which ensures policy becomes measurable code. Second, my continuous AI supported maturity assessment, which ingests live evidence from the catalogs and code repositories to prove architectural improvement over time. I lead teams to build modern platforms on Azure, Databricks, and Fabric, insisting on strict security and auditability. My goal is to operationalize data culture, ensuring that we aren't just adopting advanced analytics and AI, but doing so safely, compliantly, and with relentless focus on measurable value. Is your data warehouse struggling to keep pace with the speed of your business? Are you terrified that adding a single new data source might break your existing reports? If your architecture feels brittle, slow, or unmanageable, you're not alone. Traditional modeling techniques were designed for a different era. Today's data needs a modern solution. Introducing the Data Vault data model. Data Vault is an architectural approach built specifically for the enterprise. It is designed to be flexible enough to handle change, scalable enough for big data, and 100% auditable. It simplifies the complex by breaking your data into three structures: hubs, the distinct nouns of your business, like customers or products; links, the connections and transactions between them; and satellites, the descriptive context and history that changes over time. By separating the technical structure from the business rules, Data Vault allows you to ingest raw data at speed, creating a resilient foundation that tracks every change from every source, every time. Stop fighting your data model. Start building the legacy that lasts. I'm Ram. Welcome to our deep dive into Data Vault. Let's get to work. Let us think about the conceptual data model for some time so that we can slowly jump into the Data Vault model. Think of a conceptual data model as the architectural blueprint for your business data, even before a single brick is laid. Look at the data model behind me. Take this insurance example. We are not looking at database tables or code here. We are looking at reality. At the center, we have the policy. Who owns it? The party. What does it cover? An insured item. And when accidents happen, we file a claim. This model strips away the technical complexity to answer one simple question: what is our business actually about? It ensures that IT and business are speaking the same exact language. Welcome to the course. I know exactly what you're thinking right now. You signed up for Data Vault data modeling course. You want to see the hubs, the links, the satellites, and the SQL code immediately. You might be asking, why are we wasting time on the basics? Why are we talking about conceptual and logical models and physical models? Here is the hard truth. The number one reason for the Data Vault projects fail isn't because the code is wrong, it is because the model is wrong. Data Vault is a precision tool. It is an amplifier. If you feed it bad business logic, it will just amplify the mess. That is why in this module, we are pressing pause on the technology to master the fundamentals of data modeling. We start with the conceptual model. This represents the business reality. For example, in insurance, before we create a single database table, we have to ask, what is the difference between an incident and a claim? If you can't clearly define the distinction on a whiteboard, You have no business building a hub for it in the database. Next, we move to the logical model. This captures the business rules. Does a policy cover one car or 10? Can a beneficiary exist without a policy? Does a quote always turn into a contract? These rules dictate exactly where your data vault links will go. If you skip this step, the data vault will be technically valid, but business wise, it will be useless. Only then do we touch the physical model. This is the data vault implementation. You see, data vault is just a container of the truth. The conceptual and logical models are the truth. Finally, throughout this section, I'm going to teach you relationships using plain English nouns and verbs. Why? Because as a data architect, your job is not just to write code. Your job is to listen to an underwriter or any other business stakeholder, describe a policy, and instantly translate their words into a data model. A customer owns a policy. The sentence is your model. If you master these fundamentals, the data vault syntax will be easy. If you skip them, you're just building a faster way to be wrong. Let us build it right.
What if I told you that a simple sketch, something you could probably knock out on a whiteboard in an afternoon, could actually prevent months of arguments and literally save your company from building the wrong thing? Well, that's what we're talking about today. Let's dive into this really powerful idea, the conceptual data model. It all starts with a question that sounds so simple it's almost silly. What is a customer? But honestly, in almost any business, this one little word can be the source of just massive confusion, and frankly, some pretty big disagreements between departments. And this is where you really see the problem, right? Your marketing team, they might say, hey, a customer is anyone who ever got a quote from us. But then you walk over to the claims department, and for them, a customer is someone and only someone with a paid active policy. So what happens when these two teams try to build software together? Well, they're not even speaking the same language. And that's how you end up with broken reports, projects that just go completely off the rails, and a whole lot of frustration. So, how do you fix a communication breakdown that big? What you really need is a shared understanding, right? A single source of truth that everyone, from marketing to claims, can agree on. And this is where that blueprint sketch we talked about comes into play. Okay, so this sketch, its official name is a Conceptual Data Model, or CDM for short. And I want you to think of it exactly like the first blueprint for a house. You know the one? It shows you the big picture. Here's the kitchen, here's the living room, here are the bedrooms, and here's how they all connect. It's not showing you where every single electrical outlet is going to go. It's that high-level plan that both the homeowner and the builder can look at, point to, and say, yes, we're on the same page. And this is absolutely crucial. A conceptual model is all about the what, not the how. We're just defining what a customer is, what a policy is, and how they relate to each other. We are not, and I mean not, worrying about how this stuff is going to be stored in a database. That comes way, way later. This stage is purely about the business concepts. And you know what the best part is? This whole powerful blueprint, it's built from 3 incredibly simple components that, believe it or not, we all learned back in grade school. Nouns, verbs, and rules. That's it. Okay, first up, we've got the entities. These are basically the nouns of our business. They're the main things, the key concepts that everyone is always talking about. So for an insurance company, that's going to be stuff like customer, policy, or claim. And we just represent each of these with a simple box. Easy. Next up, we have relationships. And you guessed it, if entities are the nouns, relationships are the verbs. They're the action words that connect our boxes. They describe how two of our entities interact. So for example, a customer owns a policy. That line we draw between the boxes and that little word owns, that's the relationship. And finally, we add the rules. Now, the technical term for this is cardinality, but really, it just defines the numerical rules of the game. For instance, a key business rule might be that one customer can have many policies, right? You might have your auto policy and your home policy with the same company. But on the flip side, one specific policy only belongs to one primary customer. These little rules add the precision that makes this whole thing so incredibly valuable.
All right, enough theory. Let's actually put this into practice. We're going to build a conceptual data model for an insurance business, step by step. And we're going to build this thing in 4 really logical steps. We'll start with the core transaction, then we'll define what's actually being covered. We'll add some product details, and finally, we'll cover what happens when things go wrong.
Okay, step 1, we have to establish the absolute heart of the business. So we draw a box for customer and a box for policy. Then we just connect them with a line, and the relationship purchases, or maybe owns. That's it. This is our foundation. A customer buys a policy. Simple.
But of course, a policy isn't very useful unless we know what it's protecting, right? So for step 2, we're going to add a new box, a new entity, insurable item. This could be anything, a car, a house, whatever. And then we just draw another line. A policy covers an insurable item. See how it's growing?
All right, next, let's add another layer of detail. Think about it. The specific policy that someone buys, say for their brand new car, is really just an instance of a bigger, broader product, like the Gold Auto Package. So let's add an insurance product entity and show that a specific policy is defined by a product. And for our last step, we have to add the operational reality of the business. Because, let's face it, accidents happen. So we add the claim entity. And here's the key detail. A claim isn't filed against the customer directly, right? It's associated with a specific policy. And just like that, our picture is really starting to come together. So there you have it. We've built our basic blueprint. But, and this is a really crucial skill, you have to know when to stop. The conceptual model has a very specific job, and it's super important not to get it confused with its more detailed cousins, which come later in the process. This table here breaks down the difference perfectly. See that first column? That's us. That's the conceptual model. Its audience is the business stakeholders, and its focus is purely on concepts. Later on, a different team, the architects, will create a logical model that adds more structure. And then finally, the developers build a physical model that's the actual plan for the database. But our job today, our focus, is strictly on that very first step, just getting the business concepts right.
You know, this quote really just hits the nail on the head. In our conceptual model, we do not care that the policy number is a 12-digit string. We just care that a policy exists. That's it. We care that everyone in the room agrees on what policy means and how it connects to a customer and a claim.
So after all that, you might be asking, why even bother with this exercise? What is the real payoff here? It's actually really simple, but it's also profound. What you get is the power of a shared language.
When we look at our final blueprint, what we have is a clear, unambiguous map of the business. An agent sells a policy. A customer owns that policy. The policy insures a risk item, and a claim is filed against the policy. Suddenly, there's just no room for misinterpretation. For the first time, maybe ever, marketing and claims are finally looking at the exact same picture. And that, right there, is the bottom line. The entire goal of this thing is to force those critical conversations and resolve all that ambiguity before anyone writes a single line of code. It brings all those disagreements to the surface right at the beginning, which saves you countless hours, a ton of money, and so many headaches down the line. And that brings me to my final thought for you. I want you to take this question back to your own team. What's the one word, it could be customer, product or sale that everyone in your company uses, but if you really push them, no one can quite agree on what it means. Go find that word, because your blueprint and your whole path to clarity, it starts right there.
Time for a little exam. What is the primary audience for the conceptual data model within an organization? Business stakeholders, database administrators and developers, IT support and network engineers, data architects. If you look at the hint, consider which group is most concerned with the what of the business rather than the technical how. If you go to the next question, the context of the provided insurance model, which of the following best represents a relationship? Customer owns policy, policy number, agent, claim. If you look at the hint, think of the building blocks of a sentence. Relationships act like verbs connecting the nouns. Which of the following details would be intentionally omitted from a conceptual data model to maintain its high-level focus? The type for the policy number, the rule that a customer can own many policies, the existence of an asset being insured, the interaction showing an agent sells a policy. If you look at the hint, compare the conceptual model column with the logical and physical columns in the provided table. What does the term cardinality define within a conceptual data model? The verb phrases that describe how two entities interact, the real-world objects or concepts important to the business, the numerical rules and constraints governing relationships, the technical attributes like names and IDs of any entity. The fifth question would be, according to Lesson's step-by-step guide for building the insurance model, which entity serves as a central core transaction? A policy, a claim, customer, an agent. If you look at the hint, the guide suggests starting with the most important document that connects all other parties and events. Next question. What is the primary goal or benefit of creating a conceptual data model? As described in the source material, to define all attributes and primary foreign keys for the data structure, to document the flow of transactions through the system, to create a detailed schema for database developers to implement directly, and finally, to resolve business definition ambiguities before building software. Think about an example given regarding how the marketing and claim teams might define a customer differently. And the last question, in the insurance scenario, the relationship, a customer can hold many policies, but a specific policy belongs to one primary customer is an example of what type of cardinality? One to many to many, 0 to 1 to 1. Thank you. And answer all these things. Send me the answers in the form of comments on the YouTube video, and let me send me a private message with your email address with your answers. I will give £50 worth of Amazon coupons if you are selected by draw of lots for those people who have answered all questions correctly.
Today, we're going to pull back the curtain on something that's, well, kind of the secret architecture behind our entire digital world, the logical data model. Now, I know it sounds super technical, but trust me, it's the language that turns a simple idea into the amazing apps we can't live without. So, let's just dive right in.
I mean, think about it for a second. That app you use to order coffee, it started as just an idea, right? Hey, let's sell coffee online. But how does it remember your favorite drink, your payment info, and know exactly which store to send the order to? It's definitely not magic. It all comes down to having the right plan. You know, an architect would never ever dream of building a skyscraper without a super detailed blueprint. And in the exact same way, a developer can't build a solid app without a logical data model.
It is the master plan for all the data. So here's our game plan. We're going to cover what this blueprint is, see how it's way different from just a rough sketch, figure out who's in charge of making it, and then, this is the fun part, we're going to build one together for an insurance app so you can see how it works in the real world. Okay, so what is this blueprint we keep talking about? Well, the logical data model, or LDM for short, is really the critical bridge that connects a big business idea with the actual technology that makes it real. At its heart, an LDM does two really important things. First, it defines what data you're going to store, and second, it lays out the rules for how all that data connects to each other. Now, the key phrase here is technology agnostic. This plan doesn't care if you use Oracle or SQL Server or some brand new database. It's all about the pure, clean logic behind the data.
You know, to really get what an LDM is, it helps to compare it to what comes before it, the conceptual model. Just think of the difference between a quick idea sketched on a napkin versus the final detailed architectural drawing. They're two totally different things.
Yeah, they might look a little similar on the surface, but they have completely different jobs. The conceptual model, that's for explaining the big picture idea to the business folks. But the logical model, that's the detailed plan for the tech team that has to actually build the thing. So here's the bottom line. Business speaks in concepts, but tech builds with logic.
Let's really break this down. See how the audience totally shifts? We go from executives to architects and developers. A conceptual model might just have one box that says customer. But the logical model, oh, it lists out every single detail, every attribute, like first name, last name, date of birth. But the biggest, most important difference is right here. Keys. The logical model introduces primary and foreign keys. Think of these like the steel beams in our skyscraper. They are what enforce the rules and hold the entire structure together. Okay, so if these models are for totally different audiences, who's actually in the room building them? Well, it takes two very different teams with very different skill sets. Step one, that initial sketch, that's all driven by the business side. You've got your stakeholders, your subject matter experts. They're defining the scope. They're answering the question, what are we trying to do here? But then for the detailed blueprint, we bring in the technical experts to figure out how we're actually going to pull it off. And this is that crew. It's usually led by a data architect. Think of them as the master builder. They work with business analysts, who are like translators, turning business rules into tech requirements. And then you have your lead developers, who are the reality check. They make sure the blueprint is something they can actually build. The CEO doesn't need to know about primary keys, but for this team, that level of precision is everything. All right, that's enough theory. Let's make this stuff real. We're going to walk through building the logical data model for a super simple insurance app, one piece at a time. First things first, we need our customer. Now, every single customer needs a totally unique identifier. We call that the primary key, or PK. In this case, it's customer_ID. Then we just list out all the other pieces of information, the attributes that we need to know about them, like their name and their date of birth, which, is pretty important for insurance. Okay, next up is the policy. Of course, it gets its own unique primary key, policy ID, but here, this is where the magic happens. We add something called a foreign key, or FK, which is the customer ID. This little key creates a direct, unbreakable link back to our customer table. It guarantees we always know exactly who owns this policy. And this is it's a perfect example of how powerful this is. That one foreign key isn't just a random piece of data. It's a non-negotiable business rule that's baked right into our blueprint.
It's now impossible to have a policy that doesn't belong to a customer. The structure enforces the rule. So what about the specific coverages on a policy, like collision or liability? We could just try to cram all that into the policy table, right? But it would get so messy and you'd be repeating data all over the place. Instead, we do something smart. We create a separate table just for coverage. This whole process is called normalization, and it's all about keeping our data clean and efficient. And of course, we link it back to the right policy using a policy_ID foreign key. And finally, we have our claim table. And by now, you know the drill, right? It gets its own unique primary key, claim_ID, and it uses a policy_foreign key to connect every single claim back to a specific policy. This makes sure that we can always check that a policy is active before we pay out a claim. Okay, we've built all the pieces. So now let's take a step back and see what our blueprint actually tells us. Because with this structure all laid out, we can literally just read the business rules right off the model. See this? This little diagram shows us that one customer can have many policies. That N just stands for many. But, see the arrow? Because of our foreign key, it also tells us that any one policy has to belong to exactly one customer. The rule is right there, clear as day. And for this one, we see that one policy can have 0 or many claims. That 0 is actually really important. It makes perfect sense, right? A brand new policy won't have any claims yet. So again, the logic of the business is perfectly captured in the design of our model. So when it's all said and done, how do you know your blueprint is actually complete? How do you know it's ready to hand off to the construction crew? Well, let's run through a quick final checklist. Here's the most important takeaway. Before anyone writes a single line of code, you need to have these 5 things absolutely locked in. Your entities have to be fully defined, all their attributes listed. Every single entity needs a primary key, all your relationships are enforced with foreign keys, and your data is nice and normalized. So there you have it. With this blueprint in hand, the business team and the tech team are in perfect sync. The logic is clear, the rules are set in stone, and the path forward is totally defined. The only question left is, are you ready to start building? All right, let's talk about databases. They're the invisible engine that powers pretty much everything you do online. Now, that might sound a bit intimidating, but I promise you, we're going to break it all down. Let's just dive right in. I mean, have you ever really thought about it? How does your favorite shopping site instantly remember your address? Or how does a streaming service know exactly what you've watched? It's all about organization, but on a massive, massive scale. Finding one tiny piece of information among millions and doing it instantly, well, that's the very problem databases were created to solve. To really get our heads around this digital magic, let's forget about computers for a moment. Instead, I want you to imagine we're stepping back in time. We're walking into a classic insurance office. You know the type, wooden desks, that smell of old paper, and just rows and rows of filing cabinets. It turns out this old office holds the secret to understanding how pretty much all modern databases work. So our first stop is the heart of the office itself, the filing cabinets. This is where every bit of information lives, and how it's organized is the first big idea we need to get our heads around. This isn't just some random pile of paper. There's a real system at play here. In database speak, each one of those big filing cabinet drawers represents something called an entity. And an entity is really just a fancy word for a category of things you need to keep track of. You wouldn't just chuck every single form into one giant pile, would you? No way! You'd separate them into logical groups, into different drawers. Right, so in our insurance office, it's pretty clear what we'd have. We'd have a drawer for customers, probably another for policies, and for sure a third for claims. The label on each of those drawers, customer, policy, claim, that's what we call an entity type. It just defines what kind of stuff goes inside. Simple as that. Now, here's where it gets a little more interesting. Notice how some files kind of depend on other files. Let's say we have John Smith. He's a customer, the main policyholder. His file is what we'd call a strong entity. It can exist all by itself. But his son, Mike, is also on the policy. Mike's file is a weak entity because his record only exists because of John's. If John decides to cancel his policy, guess what? Mike's file just vanishes from the system too. It's totally dependent.
Okay, so we've got the filing cabinets down. Now let's pull open a drawer, grab a folder, and take a look at the actual forms inside. This is where we get into the real nitty-gritty details. Every single blank line on one of these forms represents what we call an attribute. So if the entity is the thing we're tracking, let's say a car, then the attributes are all the specific details that describe that car. You can think of them as the questions on the form, make, model, year, color, and so on.
And these details actually come in a few different flavors. First, you've got your simple attributes, just a single fact like color, red. Then you have composite ones, like an address, which is really made up of smaller parts like the street, the city, and the postcode. Multi-valued attributes are great because they let you have more than one answer, like a list of phone numbers. And finally, you have derived attributes, which are calculated for you. We don't need to ask for years of driving experience. We just ask for the date their license was issued, and the system can figure it out on its own. Pretty clever, eh?
Right. Now we're getting to what is, honestly, maybe the most important part of this entire system. This is the secret sauce. This is what stops the whole thing from descending into chaos and makes sure our old-school office runs with absolute precision. It's all about making sure you can find the exact file you need every single time with zero mistakes.
So let me paint you a quick picture. Imagine two new customers walk in on the same day, and they're both named James Bond. Now, one of them has a perfect, spotless driving record. The other one, well, let's just say he has a bit of a more eventful history with his cars. Mixing up their files would be an absolute catastrophe. So how on earth do you make sure you always know which James Bond is which? The solution is just beautifully simple. Every single folder that gets created gets a unique sticker slapped on it with a number. That sticker, that number, is the file's primary key. And the golden rule is this: no two folders in the same drawer can ever have the same number. It becomes the one true, unambiguous way to identify that specific record. So our careful driver becomes customer ID 101. The other chap becomes customer ID 457. Suddenly, their name is no longer the important thing for telling them apart. In our system, they are known by their number. And just like that, the whole ambiguity problem is solved. But hang on, that leads us to the next critical question. What happens when one of our Mr. Bonds has a bit of an accident? We have to create a new file over in the claims drawer. How do we connect that new claim form back to the correct James Bond in the customer's drawer? We already know that just writing his name down isn't good enough. And this is where the real magic happens. On that claim form, we don't just write James Bond. We write down his unique customer number, 101. That number, written on the claim form, is called a foreign key. It's foreign because it's the primary key from a different drawer, from the customer drawer. I like to think of it as a virtual stapler. It creates a perfect, unbreakable link between that claim and that specific customer. Okay, so let's step back out of our charming old office. Now that we understand this physical system, the cabinets, the forms, the special stickers, let's see how this all translates directly into the digital world we actually live in today. Just take a look at this. It's so clear, isn't it? Our customer drawer has just become the customer table. Each row in that table is basically a folder. The unique sticker, our primary key, is that customer_ID 101. Now look down at the policy table. Do you see that customer_ID column? That's our foreign key. That's the virtual stapler, linking policy P500 directly and only to customer 101. The filing cabinets, the forms, the stickers, it's all right there, just laid out in digital form. So there you have it, the fundamental building blocks of almost every database, all explained with a simple trip to an old filing office. The next time you log into an account or you browse an online shop, I want you to try and picture those invisible filing cabinets, forms, and unique stickers, all working away perfectly behind the scenes. And then ask yourself this: what other systems in your life are really just a digital version of this exact same office? All right, today we're going to dive into one of the most fundamental ideas in the entire world of data: database keys. They're basically the answer to this one huge question. In a system with billions of records, how in the world do you find the exact one you're looking for? Let's unlock how this all works. So let's kick things off with a question just to get you thinking. What could your social security number possibly have in common with a database? Well, the answer is pretty much everything. See, they're both trying to solve the exact same problem. How do you uniquely identify one single thing among millions or even billions of others? And that brings us right to the core idea. In a database, a key is just an attribute that uniquely pinpoints a single row of data. The best way to think about it is like a mailing address for a house. It's basically a guarantee that when you go looking for something, you find exactly that one thing. No mix-ups, no confusion. To really get this, we've got to meet the whole family of keys. We're going to start kind of broad with the big picture concepts, and then we'll narrow it down to the specific ones you'll actually be using every single day. Okay, so think of this whole thing like a funnel. At the very top, you've got the super key. That's any combination of columns that works, even if it has a bunch of extra unnecessary info. Then we filter it down to the candidate key, which is the absolute minimal set of columns you need. And finally, from all those possible candidates, we pick just one to be the star of the show, the primary key. So, you might be asking, what happens to the other candidates that didn't get picked? Well, any candidate key that wasn't chosen as the primary one is just called an alternate key. Think of it as the runner-up, still perfectly capable of doing the job. And then you've got two other really important ones to know: the foreign key, which is how we link different tables together, and the composite key, which is just a key made up of more than one column. All right, so now that we've got the basics down, you might think you're all set. But this is where we hit our first major plot twist. Using real-world data as your key, well, it can sometimes go, like, horribly wrong. Let's just play this out. Imagine this. You cleverly decide to use a person's email address as their primary key. I mean, it's unique, right? Seems perfect. But what happens a year from now when that person gets a new job and changes their email? All of a sudden, your unique identifier, it's not so permanent anymore. And now you've got a huge problem on your hands. So this kind of key actually has a name. It's called a natural key. It's an identifier that already exists out there in the real world and has a real business meaning, like an ISBN for a book or an email for a user. And like we just saw, that connection to the real world, it's both its greatest strength and its absolute biggest weakness. So The big question is, how do we solve this problem of unstable, changing data? Well, we invent a better key. This is where the surrogate key comes in to save the day. Its entire reason for existing is to provide one thing: stability. And this right here, this lays out the difference perfectly. A natural key comes from the real world, has a meaning to the business, but it can change. A surrogate key, on the other hand, is born inside the database, is completely meaningless to the outside world, and this is the most important part, it never changes. That stability, that's its superpower. So yeah, a surrogate key is totally artificial. It's just a number the system makes up, like user ID 1001, 1002, 1003, and so on. The user never sees it, they don't care about it. It has one job and one job only: to give the database a perfectly stable, unchanging identifier for that piece of data forever. Now, just when you thought we had it all figured out, we're going to level up again. There's another type of artificial key out there, but this one solves a totally different kind of problem: the problem of massive, massive scale. So let's talk about the hash key. At its core, it's pretty simple. It's just a value you get by feeding some data into a special math formula called a hashing algorithm. And what it spits out is this unique fixed-length string of characters. Okay, so why is that useful? See, unlike a surrogate key that tells you what the data is, a hash key is usually about where that data lives. The database uses the hash value to instantly calculate which physical server or partition holds that specific piece of information. It's a map, not just a label. You see this superpower in action in two main places. First, in NoSQL databases, it acts as a partition key, which basically just means it's spreading the data out evenly across a huge fleet of servers. And second, in data warehousing, it lets systems generate unique keys for huge amounts of data all at once, without creating a bottleneck. All right, that was a lot of theory, so let's make this super practical. How can you look at a database and immediately know what kind of keys you're dealing with? Let's build you a little field guide. Okay, this is basically your cheat sheet. If it looks like data you'd recognize from the real world, like an email or an ISBN, it's probably a natural key. If you see a simple number just counting up 1, 2, 3, you're looking at a surrogate key. That's the modern standard. If you need 2 or more columns just to find one thing, it's a composite key. And if you see a long, random-looking string of text, that's almost certainly a hash key used for data distribution. Look, if you only remember one thing from all of this, let it be this: if the user knows the key, like their phone number, it's a natural key. If the database assigns the key, like order ID number 5992, it's a surrogate key. And if the system uses that key to figure out a location, it's a hash key. It's simple, it's elegant, and it's so, so useful. At the end of the day, these aren't just, academic terms. They are real design choices with real-world consequences for your system stability, its performance, and its ability to scale. So next time you're building something, I want you to ask yourself, which tool are you going to reach for?
Have you ever built a perfect database only to have the business change a fundamental rule 2 months later? Suddenly, you are rewriting code, rebuilding tables, and praying that data still matches. If you have felt the pain, you are ready for the data vault. Data vault is a modeling method designed specifically for the enterprise. It is built to handle massive scale, and more importantly, it is built to handle change without breaking. Unlike traditional modeling, where we mix everything together, Data Vault separates your data into three distinct buckets based on function. We call them hubs, links, and satellites. First, let us look at the hub. Think of the hub as a core entity. It contains only the business key, the unique ID that the business uses to identify something like a policy number or a customer ID. The hub doesn't care who the customer is or where they live. It only cares that they exist. If you have the customer ID, you have a customer hub. It acts like a coat hook on the wall. It is just a solid place for hang information later. Next, we have a link. The link handles relationships. It connects two hubs together. In our insurance example, a customer buys a policy. We create a link table that simply says the customer hub ID connects to the policy hub ID. The beauty here, if the relationship changes, say the customer transferred the policy to someone else, we don't touch the hubs. We just update the link. It keeps the structure flexible. Finally, and the most importantly, we have the satellite. This is where the context lives. The satellite holds all the descriptive attributes, the adjectives we talked about earlier, names, addresses, phone numbers, premium amounts. Satellites attach to hubs or links, but here is the magic trick. Satellites track history automatically. If John changes his phone number, we don't overwrite the old one. We simply add a new row to the satellite with today's date.
All right, let's dive into a really powerful data modeling technique called Data Vault. Now, it's designed to solve some of the biggest, most frustrating headaches in data architecture. And trust me, if you've ever worked with a complex data system, you are going to want to see how this works. So, does this sound familiar? Your company makes a seemingly tiny business change, like a new rule for a product, and suddenly it triggers this massive, super expensive IT project. It's a classic headache, right? And it almost always comes down to how we've built our data systems from the ground up. And that brings us right to our first topic. What happens when data models break? The real reason these systems can be so fragile is that, well, the models they're built on are often designed for very specific and pretty rigid purposes. Yes, so we usually see two main approaches. On one side, you've got your classic ER models. These are fantastic for the applications that are actually capturing the data, like your sales CRM. And on the other side, you have star schemas, which are amazing for analyzing that data in reports. Now, both of them are great at what they do, but here's the catch. They're not very flexible. You change one little business rule and you might have to completely rebuild the structure, which in turn breaks every single report that depends on it. Ouch. So if those models are too rigid for building a big enterprise-wide data foundation, what's the answer? Well, this leads us to the single most important idea behind the Data Vault methodology, and that idea is separation. So here's what we're talking about. A data vault isn't really for capturing data, and it's not for reporting on data either. Its number one job is to store and integrate data from all over the company, and to do it in a way that doesn't shatter into a million pieces when the business changes. It's literally built for the long haul. And it pulls this off by following a really interesting philosophy. All the keys, all the time, regardless of the relationship. Now, what on earth does that mean? It means Data Vault makes a radical split. It separates the stable, core pieces of your business, we call them the business keys, from all the messy, constantly changing relationships and details that surround them. Okay, so how does it actually do that? How does it make that separation happen? Well, the entire model is built from just 3 simple, distinct tables. Let's break them down right now. First up, we've got the hub. The hub's only job, its entire reason for existing, is to store a unique list of business keys. Just think of things like a customer ID or a policy number or a product code. It represents a core business thing and absolutely nothing else. Let's use an insurance company as an example. A table called hub_policy would just be a list. A simple list of every single unique policy number the company has ever issued. It has no idea who owns the policy or how much it costs. It just says, hey, this policy number exists. That's it. This is the stable anchor for the whole model.
Okay, next up is the link. Now, if the hubs are the nouns of our business, the people, places, and things, then the links are the verbs. Their only job is to create a relationship or record a transaction that connects two or more of those hubs. Back to our insurance company. A table called link_policy_customer would be dead simple. It would just contain a policy ID from our policy hub and a customer ID from our customer hub, sitting right next to each other in the same row. All it's telling us is, hey, this customer is connected to this policy.
Now, this is where the magic really kicks in. Let's say one day the business decides that a single policy can suddenly have multiple owners. In a traditional model, that could be a huge, painful redesign. But in Data Vault, you don't change a thing. You just add more rows to the link table, connecting that one policy to a few different customers. The model just soaks up the change without any drama.
So we've got our keys in hubs and our relationships in links. But where's all the juicy stuff? The details? That's the job of our final building block, the satellite. Satellites literally hang off of the hubs and links, and they store all the descriptive, contextual, and historical details. And to finish off our analogy, a sat_policy details table would be attached to our hub policy. This is where you'd find all the rich information that's likely to change over time, things like the premium amount, the policy start date, or the type of coverage.
So you've got hubs for the keys, links for the relationships, and satellites for all the context. When you put these three simple pieces together, it unlocks some really incredible advantages. We're going to call them Data Vault's superpowers.
This structure basically gives Data Vault 3 superpowers. First, because of the way it stores descriptive data, you get a perfect auditable history of everything. Second, it gives you that incredible agility and flexibility we talked about so you can adapt to business changes. And third, because the components are so simple and independent, you can load data into them incredibly fast, all at the same time.
Now, that first superpower, the audit trail, is probably the most important one. And here's the secret. Satellites are almost always insert only. That means when a customer's address changes or a policy's premium goes up, you never, ever overwrite the old data. You just insert a brand new row in the satellite with the new info and a timestamp. And just like that, you have a perfect built-in historical record of every change that's ever happened. It's automatic.
Okay, this all sounds pretty great, but how does Data Vault really stack up against the models that most of us are using day to day? Let's put them side by side for a final showdown. This table really makes it crystal clear. A traditional 3NF model, that's what you want for your transactional apps. A star schema, it's purpose-built for reporting and BI tools. But Data Vault, its sweet spot is building that integrated, central enterprise data warehouse. And when you look at the things that really matter for a data warehouse, like handling history and being resilient to change, well, you can see Data Vault was just born for this, while the others can be pretty brittle.
So if you take one thing away from this, let it be this. Each of these models is a tool for a specific job. You wouldn't use a screwdriver to hammer a nail. Data Vault's unique and incredibly powerful job is to build that central, flexible, scalable, and completely auditable data foundation that the rest of your company can build on top of. And that just leaves us with one final question to think about. What could your organization actually build if your core data foundation was no longer brittle, but was truly, actually future-proof? Thanks for tuning in.
Hello and welcome. Today we're going to do something a little different. We're not just going to list off definitions for Data Vault. No, we're going to step inside the mind of a data architect.
We're going to uncover the strategic blueprint they use to turn a simple data model into a really powerful, scalable data warehouse. Right then, let's get into it.
And this quote, honestly, it just hits the nail on the head, doesn't it? Look, anyone can memorize that a hub is a table that holds business keys. That's the easy part. The real skill, that architectural mindset, is knowing which business concepts deserve a hub in the first place. That is the leap from developer to architect, and that's the journey we're on today.
So before a single piece of code gets written, before any tables are created, the architect has to think. They've got to lay the groundwork. And for us, that foundation is built on 3 absolutely critical strategic decisions. You have to get these right from the start.
And here they are, our 3 pillars of thinking. First, the hub strategy. This is where we define our core business entities. Then, the link strategy. That's how we map the relationships between them. And finally, the satellite strategy, which is all about describing those things. Now, let me be clear. Get these wrong, and you are not building a data warehouse, you're digging a data swamp.
So, let's start with the hubs. The mission here is to find the true business key. And what's so important to understand is that we're not just looking for a primary key from some source system. Oh no. We are on the hunt for the golden key. That one true identifier for a business concept, like a customer or an insurance policy, that stays the same no matter what systems you use now or in the future.
And this just lays out the challenge perfectly. You might think a social security number is a great unique key, but it's a huge privacy risk, an absolute no-go. A system ID? Well, that's just brittle. It'll break the second you migrate to a new system. The real golden keys, the ones we want, are truly unchanging. Things like a unique policy number, or maybe a cleverly created hash of key customer details. You have to really profile your data to uncover these gems.
Okay, so moving on to our link strategy. This builds directly on our hubs. See, a link isn't just a technical join table. It has to represent a real-world business event. We call this the unit of work. It's all about defining the granularity, the very essence of the relationship with real precision.
So let's think about this, using our insurance example. When a policy is sold, what is that actual event? Is it just a connection between a customer and their new policy? Or is the agent who sold it a fundamental part of that transaction? Your answer to that question completely changes how you build your link.
And this is why it's so important. By correctly identifying the grain of that transaction from the beginning, you build a model that's robust, that's future-proof. It won't shatter into a million pieces when, down the line, the business wants to start tracking sales by a new dimension, because you've already captured the true essence of the event.
Right, and that brings us to our 3rd strategic pillar, the satellites. This is where the real performance and efficiency of your data vault is either won or lost. I like to call it the art of separation. The strategy is actually quite simple. Whatever you do, don't just dump every single descriptive attribute about an entity into one giant messy table.
Instead, we get clever. We separate them by how often they change. I mean, think about it. A customer's wallet balance might change every single day, but their date of birth, that's never, ever going to change. By splitting these into different satellites, we make our model incredibly efficient, both for storing the data and for querying it later on. Okay, so with our strategy locked in, we can finally move from the thinking phase to the building phase. But this isn't a free-for-all. Building a data vault requires a very disciplined, very specific, hierarchical process. And this is it, the loading hierarchy. It is absolutely non-negotiable. First, you stage your data, then you load the hubs, then you load the links, and only at the very end do you load the satellites. You have to follow this order. It really is like building a house. You pour the foundation before you even think about putting up the walls. So step 1, staging. The best way to think of this is like a prep kitchen for a chef. We're not just throwing raw data into our warehouse. No way. Here, we clean things up, we hash our business keys to create those unique identifiers, and we add crucial metadata, like when the data was loaded. It's all about preparation. Next up, we pour the concrete foundation by looting the hubs. We take all those nice, clean, hashed business keys from our staging area, find the unique ones, and populate our hub tables. The logic is simple, but it's so important. You can't link 2 things together if they don't even exist in your warehouse yet. With our foundation solid, we can now start putting up the steel frame. We load the links. This is the step where we actually connect the hubs we just created, building out that core framework of our model and defining how all those business concepts relate to one another. And finally, we get to add the paint and decorations. We load the satellites. This is where we attach all of that rich, descriptive context to our hubs and links. This is also where the magic of history tracking happens, as we check for any changes in the source data and create new records to capture that history. So you might be thinking, wow, that's a lot of work, a lot of discipline. So why do we go through all this trouble? Why stick to this strict blueprint? Well, because it's not just theory. This approach delivers tangible, real-world results that you can actually see and measure. Remember that art of separation we talked about? Well, by being smart and splitting our satellites, we're not just being neat and tidy. We are potentially saving millions of bytes in storage costs because we're not wastefully repeating static information like a customer's name over and over and over again.
And that saving in space translates directly into a saving in time. It's just faster. As you can clearly see here, when a query only needs slow-changing data, it doesn't have to sift through a massive table bogged down with all that fast-changing stuff. The result? Dramatically better query performance. It's a game changer.
You see, this whole blueprint, from the high-level strategy to the disciplined build process, it just sets the stage for the practical, hands-on work. The next logical step, really, is to take this architectural thinking and translate it into the actual SQL code that would bring a real insurance data model to life. So, today we have traveled all the way from just knowing what a hub is to really understanding how an architect actually thinks, how they strategize, how they plan, and how they build for resilience, for performance, and for scale.
So the only question I have left for you is this. Are you ready to take that next step yourself? To move beyond just knowing the definitions and start truly becoming the architect? Thanks so much for joining me.
Knowing just about hubs, links, and satellites will not make you a data vault data modeler. If you have to become a specialist, you need to know how to set up the strategy for hubs, how to set up the strategy for the links, and how to set up the strategy for the satellites, and how to present data. So, for that matter, we will be discussing all these considerations in our next video. Thank you for watching me.